Hello, everybody. Thank you for including me in this panel on multimodal AI and its making of Asian media histories. I'm so glad to be following the talks that happened before me. I'm making this recording because I'm unable to travel to Vancouver, so I wish everyone the best over there, and I wish I was there. Hope to meet you soon in a room. I'm going to be talking about multimodal AI in the context of music and Indian music, which is where I am from, India. But before I proceed, I wanted to do a simple sound check because I'll talk about music. Let's see if we can hear this sound. Hopefully, we can. I hope that was loud and clear in the room. Um, I want to introduce myself. My name is Manaswi Mishra. Here's a picture of me when I was 4 years old, and you can see I'm wearing headphones just like right now, and I have these cassette tapes in front of me. When I was 4 years old, my parents introduced me to the idea of music and sound and gave me this cassette tape recorder machine, and I recorded a lot of sounds, including my own voice singing songs and rhymes when I was 4. And few years back, I went back to my house and found these cassette tapes and listened to the sounds, and I made a AI model out of my 4-year-old voice. And so I wanted to play a message for all of you from my 4-year-old self.
Hello, AAS conference. Thank you for having me speak on this panel.
You can hear my voice, my accent is all captured in that data set. I can do something that was never possible before generative AI, which is make new messages, make new songs in the voice of myself as a 4-year-old. You can also hear the qualities of the data set, the recording quality, the microphone in my mouth almost. It's an interesting possibility which generative AI unlocks for us. And my work has been to focus on a very particular kind of technology, which is multimodal and sociocultural, which is the musical instrument. Now, if we look at the history of musical instruments, here are some pictures of musical instruments that you might recognize. On the top left over here, we have one of the earliest known musical instruments, the bone flute from 50,000 years ago. We notice that from carving tools, as we have new technologies appear, we have new musical instruments. So we have woodwork and we have wooden instruments. Then we have metal extraction, so we have metallic instruments. Now we enter into the age of electronic instruments, all the way to how music is made today on iPads and touchscreens. With every new technology appears a new musical instrument. Now, a newer musical instrument is not a better version of a previous musical instrument. A guitar is not better than a violin. Neither is the violin the same instrument when played in Europe versus when it's played in India. They're all different languages of exploration, which is why musical instruments are a great way to understand how technology is proceeding. Now, as we look at different technologies and how we have made musical instruments out of it, it helps us think what is coming next, what kinds of generative AI musical instruments are possible. So I look at what are the technologies of today. We have large data sets and recordings, and we have incredible pattern matching, pattern understanding AI models. So the possibilities of making music with these large recordings and pattern matching machines seems incredible. And composers before us have imagined such futures. We have Zakir Hussain thinking about the musical possibilities as a universe to be explored. We have Herbie Hancock's musical album here, where he's thinking of himself as an inner rocket ship. And this is how I imagine that AI musical instruments, as we start building them, will allow us to do things that were never possible before, mix ideas together like a rocket ship of possibilities. But actually, the AI musical instruments we see today look just like this. They are a box that you request music from. Give me a song. Give me a song with an amazing guitar solo or something that sounds like this artist or this style. This seems very transactional and seems only like scratching the surface of the kinds of musical instruments that should be possible with generative AI. I'm going to show you a few of such examples of generative AI tools for music making that we are working on at MIT. I'm a PhD student and I get to work on these AI musical models for live performances. Now, you might have thought about how I can write a text prompt and say, give me a rock song, and it gives me a rock song. But here is an example of where you might go from audio and sing a melody like ba-da-ba-doo, ba-da-ba-doo, da, and try to get music out of it. So audio can be represented as a waveform, which is this timeline, and these pressure waves represented as a graph in time. Or it might be represented as an image, like here's an image of the sound, a spectrogram that represents the frequencies present in it. So we can use the incredible image generation tools to go from an image of sound to another image of sound. So here's an example of me singing an Indian percussion sound. Tum, tuka. Let's listen to it. Tum, tuka, 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 tubu-tubu-dum, tuka, 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 tubu-tubu-dum, tuka. Now, I take that sound and transform it and make it sound like this through these generative AI models. You can see it follows the structure of the sounds that I made, but now it sounds like many instruments. Let me also show you a live version where I can take the sound of my voice in a microphone and translate it using this kind of AI model that is trained only on percussion sounds to take my voice, tum tum tum, and make these percussion sounds out of it. Taka takita, taka takita, taka takita, ta doom, taka takita, ta doom. Taka takita, taka takita, taka takita, taka takita, taka takita, taka takita, ta doom, taka takita, taka takita, taka takita, taka takita, ta doom. It's incredibly powerful what is possible with this. So I want to present to you a case study of the paper that we are presenting here, which is the Sitar AI Jugalbandi. Now, maybe some of you are familiar. The sitar is this beautiful instrument you see over here, this 1,000-year-old history. And here you see my friend Mansoor Rahmat Khan, my collaborator, who's a seventh generation sitar player in a family of sitar players. And me, we are trying to do this Sitar AI Jugalbandi, where we have a performance that goes from AI to sitar and voice and allows us to explore a cultural musical possibility rather than just an interesting computational object. Now, I will show you some examples of this and how we presented this idea. We got to present it in a performance at the 50th anniversary of the Computer Music Conference that happened last year. We had an incredible audience of musicians, technologists, and what we did was this Sitar AI Jugalbandi. Now, the word Jugalbandi in Indian music refers to entwining twins. So there are two soloists and they are intertwined. And that's what a Jugalbandi is. It's where a structure for improvisation where two solo instruments improvise with each other. And here is an example of how it looked on stage. There was me on this side with my microphone and my computer that was running these AI models, and Mansoor on the other side with the sitar, playing the sitar and improvising along with me to do a jugalbandi between these two soloists. So the first case that I want to present to you is a way that the Jugalbandi worked from the sitar to an AI model. So the sitar would play something that would get transformed by AI models in a live context. Let's listen to what this would sound like. So here's an example of Mansoor, and he's going to play the sitar. And the first thing you will hear is the AI trying to recreate that sound by imitating the same kind of waveform. It's kind of interesting, this weird texture that follows as the AI model is quickly trying to create the waveform that is in response to what he's playing on the sitar. From that, we explored the same kind of idea of going from his sitar playing to through a diffusion transformer model. So what he is playing, I record that snippet and then I run it through a diffusion transformer to generate voices. So what you're going to notice now again is his sitar playing. And then me on the computer, I am recording a snippet of that sitar and synthesizing in real time the sound of different voices that try to continue that audio waveform. But instead of sitar, they try to continue it in the sound of voices. So that is the recording, and now you will hear the voices come in. to pause it there. So in this examples, you saw like a sitar to AI kind of Jugalbandi. And now I will show you the opposite type, which is where AI would make a sound and the sitar would respond to it. In this case, I was also controlling the AI with my voice. So I would sing and my voice would get converted into the sound of percussions. And we ended up doing a cycle of Jugalbandi where we play call and response to create a sum and increase the different kinds of time signatures explored. So the first thing you will hear is the way it works, where my voice becomes the sound of tabla and percussion. And then you will hear both of us playing back and forth in the same setup. I'm just going to pause it here. Before I continue, I want to say that these AI musical possibilities really depend on the constraints and context of the music that is being performed. At the Media Lab, I get to work with opera musicians and symphony musicians as well. And we explore how musical AI models can be controlled on a live stage by everything from a chamber orchestra to the symphony orchestra. And the sounds of the music and the AI don't necessarily have to be one particular model, but I want to present that there are AI models that are like the language models of the time. So they are large, they have been trained on all kinds of text, and they're supposed to know all of the knowledge of text. Similarly, we have large models for music, which know all of the different types of music, scrape the internet with unethical and ethical ways. We have open source models being released now, and also deals being made between different music asset holders like labels and the AI music companies. As we enter into this age, I want to present another kind of AI that has been very powerful for us, which is a small AI model trained on just 2 to 3 hours of a particular instrument, a particular cultural representation. So you just heard the percussion, but let me show you another example, which is where I go from my voice, and you hear my voice right now, to an AI model that we trained on just the sound of a particular river. And so my voice becomes the sound of a river. Shh, shh, bloop, tak, tak, shh. As you notice and hear my voice get transformed into water, we have done similar examples with chamber musicians and opera musicians, and I want to show you like a quick example of what something like this might look like. So here you see a piece where we have a composer, a conductor, Todd Macover over here, and a chamber group, the Sejong Soloists. And I'm sitting on stage back here, and I'm receiving microphone input from all these musicians, and I'm letting their violins control the sound of the water. And I'm going to play a specific moment where these musicians improvise, and what they play gets transformed into the sound of this river. So you again see how a chamber group is able to get different kinds of sounds out of the system. With this, I want to present different multimodal ways of making musical AI systems, and the fact that it's very important to think about the context, the constraint, and build the kinds of AI musical tools that we want to see in the world that expand the possibilities of creativity rather than automate what is possible and how humans can be creative. Thank you so much for listening to this recording.